Okay, so good afternoon, everyone. Thank you all for joining us for the Love Data Week webinar series. This session is facilitated by Dr. Ahmad Pratama. His presentation is called Finding Open Data for Your Projects. If you have any questions throughout the session, please leave them in the chat. And without further ado, I'll hand it over to Dr. Pratama.
Thank you, Link, for the introductions. Hello, everyone. Good afternoon, and welcome to Finding Open Data for Your Projects. So my name is Ahmad Pratama. I am the Data Literacies Lead here at the University's Library. I'm excited to be part of the campus-wide Love Data Week campaign, where we celebrate all things data and how it can help us not only in our research and teaching, but also in everyday decision-making. So here's a quick look at what we'll cover in the next 30 minutes. First, we will start by clarifying what open data is and why it matters. And then we'll do a quick poll to get the sense of who's in the room and what kind of data you are interested in. And then we'll discuss key tools and resources that you can use to find open data. And I'll share some tips for evaluating datasets once you find them. And finally, we'll open it up for questions and wrap up with a few key takeaways. So, what is open data? Let's define what we mean by open data first before we go further. So in simple terms, open data refers to any data that can be freely used, reused, and redistributed by anyone, subject only at most to the requirement to attribute and share alike. So some hallmarks of open data are, first, it is usually publicly accessible online. So you can just see there's like a specific web page or even like a website or portal where you can just access the data. And second, it usually has a license that ensures it's openly available. And third, it might require that you at least give credit to the original data provider. So open data can come from governments, research institutions, or other organizations looking to make information freely available. So why is open data useful? There are at least three main benefits here. First is academic and research benefits. The second is professionals and industry benefit. The third one is community and public good. So let's start with the first one. Open data in academia, in terms of academic and research benefits here. So open data significantly enhances the reproducibility of research. And this is important because this is the cornerstone of scientific integrity. You know, because scientific breakthrough is, done by making sure that something is reproducible. By making data openly available, researchers and so other researchers can validate and build upon each other's work. So this will lead to faster and also more robust discoveries. This collaborative approach not only accelerates the pace of innovation, but also ensures that research findings are reliable and can be independently verified. For example, the Human Genome Project, which made its data publicly available, has enabled countless breakthroughs in genetics, medicine, and biotechnology by allowing researchers worldwide to access and build upon the genomic data. And in the professionals and industrial sectors, open data is also a valuable resource for making informed data-driven decisions. Access to open data eliminates the need for costly proprietary data, allowing businesses and organizations to leverage existing data sets to optimize operations, identify market trends, and drive innovations. This democratization of data fosters a more competitive and efficient marketplace. For example, some companies in agriculture sector use open weather and climate data to improve crop yields and manage resources more efficiently, leading to better food security and reduced costs. So yeah, they don't have to worry about like weather because they can just utilize the weather or the climate forecast that's publicly available out there. So yep. And finally, on a broader societal level, open data promotes transparency, civic engagement, and also accountability. When governments and public institutions publish open data, they empower citizens to understand and engage with public issues more effectively because they have the data. So it's not just based on like and dislike one or something like that, but it's data driven, so it's backed by data. Um, this transparency helps build trust between the publics and also the institutions, encourages informed public discourse, and enables citizens to hold their governments accountable. Open data also supports community-driven initiatives and solutions, enhancing the overall well-being of society. But just because open data offers a lot of benefits doesn't mean all open datasets are inherently reliable. So first, it's crucial to assess the credibility of the source. When evaluating data, we need to consider its origin. Data from established organizations or institutions like government agencies and universities tend to be more trustworthy due to their rigorous standard and accountability. And we also need to ensure the accuracy of the data. We can do this by verifying it through peer review or cross-referencing with other reputable sources. It doesn't have to be us. It can be done by someone else. But when the data has been through peer review or cross-referencings, then we know that the data is it's more likely to be accurate than data that it's just uploaded by someone or posted by someone without any peer review or cross-referencing done. So peer-reviewed data has undergone scrutiny by experts in the field, which adds a layer of reliability. Cross-referencing with multiple reputable sources can also help confirm the data validity and identity, and also identify any discrepancies in the data. And third, consistency is key. So reliable data sources update their data regularly and also provide historical records. Some data may no longer be updated because it has reached a point where further updates are unnecessary or irrelevant. For example, data from a completed census or finished research project, or maybe certain epidemic or pandemic, for instance. So yeah, the key is that the data was accurate and relevant at the time it was collected and continues to be useful for historical analysis and reference. And finally, transparency is also essential. We need to look for datasets that clearly explain their collection methods and methodologies. Transparent datasets provide detailed information on how the data was collected, processed, and then analyzed, allowing users to understand the context and also the limitations of the data. So by understanding this, we know that what kind of analysis and what kind of insight that we can get from the data, and what kind of question that we cannot answer are based on the existing data, or what kind of further data that we need to collect because of the limitations of the existing data. So this transparency and helps ensure that the data can be accurately interpreted and also used appropriately. So by carefully evaluating these aspects, we can confidentially utilize open data for any of our projects. So before we move on, let's do a quick poll to see who's here and what your data interests are. So yep, there are just two questions here. What is your main role? Just pick one. And then the next one will be, this is the first question. So let's just give it some time for people to answer the questions. Okay, looks like we have a mix here, good mix of stuff. Most of our audience here, more than 50% are staff, followed by faculty, students. Yeah, great. Thank you. So, yep, let's share the result. Okay. Yep, perfect. So let's move on to the second questions. So what types of data or like background that you have, what kind of data here? So you can pick more than one um, option here. I would say it's quite balanced. Okay, yep. We have a mix of roles and also backgrounds or fields of interest here. So this is fantastic. So yeah, I'll keep your interest in mind as I talk about resources later on. So yeah, I'll be sure that I try my best not to you know omit any field here. So yeah, thank you, Ling, for the poll. So let's move on to the next slide. Let me just close the. All right, so some key tools and resources. Let's dive into some of these, main tools and resources for finding open data. My favorite tool here, my favorite tool is Google Data Search. So this is an excellent broad search tool that aggregates metadata from across the web. It's very user-friendly. You can just type in your search term as you would on Google. It's just like Google Search or Google Scholar, but this is for datasets. We'll take a look at Google data searches later. So let's move on to the second one is government repositories. For instance, in the US, we have data.gov. And the European Union, in Europe, they also have EU data portal. These official sites from the government often contain a wealth of data on everything from demographics to economic indicators. But yeah, the data is only relevant to their specific region. So obviously data.gov will be any data related to the US population, whereas EU data portal will be for European Union population. And then the third one, we also have institutional repositories. So some universities maintain their own data repositories. So in-house data repository. This can be particularly useful if you're looking for research datasets generated by specific institutions, for instance. There's also another options where universities collaborate with data repository platform like Dryad, for instance. This is in our case, yeah, we have a collaboration with Dryad, and our university libraries offer a dedicated research guide on Dryad. The link is on the slide, and I think we can share the slide with all participants after the workshop ends later today. So yeah, you can check out on like key information, so complete guidance on how you access these datasets on Dryad and how you can submit your own dataset to Dryad. And then finally, we also have third-party repositories, platforms like Kaggle, Figshare, or Zenodo, for instance. Kaggle is well known for machine learning computations, but it also hosts a large collections of user-contributed datasets. It's very famous among the data science enthusiasts. So yeah, they so in many cases they don't just share the datasets but also the code. So if you're interested in learning about how to analyze data, for instance, you can go to Kaggle, download the data and also the code associated with the data. So you can try to replicate the what kind of existing analysis that they already did before with that specific database or data sets. So yeah, it's helpful not only for research project, but also for learning project. If you're trying to learn on how analyze the data, or even like for some folks in engineering, computer science, for instance, how to learn about machine learning, for instance. Yeah, it's very famous. That's Kaggle. Figshare and Zenodo are popular for academic and scientific data sharing. So Zenodo in particular is highly popular in Europe, I believe. Yeah, I believe it's highly popular in Europe. So yeah, each platform has strengths depending on your project need. So let's take a quick look at how Google dataset search works. So you can just type in on your web browser Google dataset search, and this is how it looks like. So you'll notice it looks very similar to a standard Google search because this is Google. But it will, whatever search term that you type in here and you search, the results will be datasets, not web pages. Just like if you're searching on Google Scholar, the result will be like scholarly articles, even though it's different from the library database, which is like collections of journal. On Google Scholar, it can be anything actually, like in preprints and something like that as well. So yeah, it's a good starting point, I would say, the same as Google dataset search. Here, I'll just try, the one that they provide already over there. So coronavirus COVID-19, I'll just click on that one as a quick example. And this is how the search results look like. So as you can see here, there's some filters up there. You can, yeah, there are some filters for last updated and then download format, which is like file format, and also the usage right, topic, provider, and also whether the data is free or not. So yeah, once you have, so on the left sidebar, there's the results. So the results is on the left sidebar, whereas on the main screen on the right, center and the right, this is the informations about the data set. So it will provide informations about like the search page, and then you can also see some documentations over there, the information about who provide the data, and yeah, and format as well. So the key takeaway here is that Google Dataset Search is a fast way to get an overview of what data might be out there on your topic of interest. So finding a dataset is only half the battle. You need to make sure that the data is suitable for your project. So here are some criteria to keep in mind. First, check data quality. We discussed this earlier already, so I'll just briefly mention it again as a reminder, because it is so important to make sure that your data source is reliable. Because if your data is not reliable, whatever project that you're doing after that doesn't really matter, because the data is not reliable. The conclusion will be incorrect. So yeah, that is, I can't emphasize this enough. So make sure to check the data quality, the source reliability. Okay, so next one is metadata and documentation. So make sure that the datasets provides clear column headers, definitions, and any relevant context. This can avoid you from headaches down the road, because if you just download the data and start analyzing it without reading the documentation or making sure that it has proper metadata and documentations, you might risk wasting a lot of time down the road. So yeah, you don't want to do that. Make sure to check the metadata and documentation first before you start working on the data set. Third is about licensing and permissions. So look for open licenses such as Creative Commons or Open Data Commons, and also check if you need to provide attributions or if there are any restrictions. Some data are free to use for non-commercial purpose only. Some other are you can use for commercial purpose, but you have to pay for it, for things like that. So yeah. And then finally, check the format and whether it's easy to use or not. So ideally, it uses open format like CSV, comma separated values, or JSON, JavaScript's object notation, or at least spreadsheet format like Excel, for instance. These formats work easily with your tools. So instead of proprietary format that requires you to have like other software that is not free. So, and yeah, let's revisit the previous example. The first search result is a dataset provided by the New York Times, hosted on GitHub, as you can see here. So that's the information. It's available on GitHub, and then it's provided by the New York Times. And there's also information about license and also some descriptions of the dataset. And if you click on that link, it will bring you to GitHub. This is the GitHub, how the GitHub page looks like. And as you can see, they clearly explain the methodology used to collect the data. And they also provide definitions on all terms used in the datasets. This is what high quality datasets looks like. You won't have to spend unnecessary time trying to figure out what each column is with this kind of high quality data. In terms of license, they also made it clear that the New York Times provide this dataset under a free, perpetual, non-exclusive license for non-commercial use. But they also require anyone who uses these datasets to give proper attributions. They don't stop that, so they also allow for commercial use, but permission is required. And because this is free, I believe you don't have to pay, even if, like for instance, this is important for those who are interested in developing non-academic projects, like building a startup or an app, for instance. You can use this data. This is the same data set that they use to work on their news articles and visualization charts like that. So yeah, this is helpful. This is very useful. So, and finally, we can see here, this is the dataset format provided in CSV, comma separated value, non-proprietary. So this is open format, and it can be, it's compatible with a variety of tools. Spreadsheet applications, Excels and Google Sheets can open it like native, and then data visualization platforms like Tableau or Power BI can also open it without problem. And also, if you're working with programming languages like Python and R, it's so easy to load CSV file. So this flexibility ensures that you work with data using your preferred tools without compatibility issue. And let's take a look at some other examples of reliable data sources. Government data sets, like in addition to data.gov, we also have US Census Bureau, established organizations like United Nations, World Health Organizations, OECD, and World Bank. They offer comprehensive global data, especially if you're looking for cross-country analysis or worldwide analysis, things like that. And then peer-reviewed academic research like Triad, Zenodo, and Figshare. And finally, trusted online platforms like Our World in Data and Statista. Unfortunately, for Statista, they are not free. So Statista is not free. We have to pay a lot of money for, and I don't think we have that subscription here. Our World in Data is free though. So this trusted online platform, they don't collect data directly themselves. They compile and present data in a way that's accessible and easy to interpret. So they provide methodology on how they compile the data. And there's even more options here. If you're looking for government and public sector data, data.gov, NOAA, or NASA. Social science folks, you can go with ICPSR. That's always a good one. Pew Research Center, or the General Social Survey. For business and finance, there's also Asian Development Bank or Inter-American Development Bank or the African Development Bank if you're looking for more regional data and also of economic and policy related. Crowdsources, open data platform like Kaggle or GitHub Open Data, or international organization like ITU, International Telecommunication Union. I used some of these data sources in my dissertation back in the day. So yeah, I'm so grateful of this open data set. So yeah, these sources cover a broad range of topics, giving you access to diverse data sets for research, analysis, and decision making. So key takeaway, we'll start broad. So use general search tools like Google Dataset Search to get an overview of available open data sources for your project. And then make sure to evaluate the data carefully, verify the source credibility, licensing terms, and also the data format to ensure the data sets meets your project requirement and also your needs. And finally, you might need to consider domain-specific repositories as well. So you can also explore specialized or institutional data repositories when your project needs more targeted or discipline-specific data. These steps will help you find and use open data more effectively. So I think we still have 4 more minutes. I want to open up for any questions you might have about finding or evaluating open data. Feel free to type your questions in chat or use the raise hand feature if you'd like to speak.
Have you ever linked open data source to a Excel spreadsheet so that it's dynamic, that it automatically updates?
Yes. Well, it really depends on the nature of the data source as well. If it's dynamic, sometimes it's well, you said Google Sheets, right? Or Microsoft Excel?
Excel.
Excel. Okay. So in Excel, I'm not sure if they have in Google Sheets there's import range or import HTML. I think there is something similar in Microsoft Excel as well. So you can actually retrieve the data set automatically, or retrieve data from a table, an existing table from a web page or something like that, and then work directly from Excel or Google Sheets. Yes.
Thanks.
I will have to look further about the technical
I
technicalities.
think with Power BI, that's something you might be able to. Power BI is like, I guess, the version.
Sure, yeah.
I had a tiny bit of training.
Yeah, we can discuss further if you're I can to be honest, I use Google Sheets more than I use Microsoft Excel. So I will have to double check whether things that work in Google Sheets also work in Excel. But yeah, I can definitely check it out, and yeah.
Okay.
Feel free to email me, and then we can discuss it later.
Okay. Thanks.
You're welcome. Any other question?
All right, we are at time. Yeah, thank you so much, Dr. Pratama, for a very informative presentation. And happy Love Data Week, everyone.
Happy Love Data Week. Thank you for joining the workshops.
Bye.
Bye.